Let's study the next problem. The mass of Earth is 6 into 10 to the power 24 kg. The distance between the Earth and the Sun is 1.5 into 10 to the power 11 meter. If the gravitational force between the two is 3.5 into 10 to the power 22 Newton, what is the mass of the Sun? My dear student, the gravitational force between the Earth and the Sun is given to us. My dear student, the mass of the Earth is given to us and we have to find the mass of the Sun. My dear student, let's try to solve this problem. Let the mass of Earth be m1, which is equal to 6 into 10 to the power 24 kg. Let the mass of the Sun be m2, which we have to find. The distance between them is r and it is given 1.5 into 10 to the power 11 meter. The gravitational force between them is given and that is 3.5 into 10 to the power 22 Newton. The value of G is given and which is 6.7 into 10 to the power minus 11 Newton meter square kg square. Let's solve the problem. Answer: F is equal to G m1 into m2 upon r square. My dear student, here we have to find m2. F into r square, r will take to the other side of the equation, is equal to G m1 into m2. F into r square is equal to m2 will keep as it is and G into m1 will take to the other side of the equation. It will become G into m1. My dear student, we have arranged the formula in such a way that we got a formula m2 is equal to F into r square upon G into m1. But what is m2? m2 is mass of the Sun. So our formula is correct. Now my dear student, let's put the value. m2 is equal to force is given. The gravitational force between them is 3.5 into 10 to the power 22 Newton into r square is given. But what is r? The distance between the Earth and the Sun, and the distance between the Earth and the Sun is 1.5 into 10 to the power 11 meter square. My dear student, here the value of g is given and the value of g is 6.7 into 10 to the power minus 11 Newton meter square per kg square and into m1, that is mass of the earth. It is also given 6 into 10 to the power 24 kg. My dear student, here I have put all the values in our formula. M2 is equal to 3.5 into 10 to the power 22 into 1.5 into 10 to the power 11 whole square upon 6.7 into 10 to the power minus 11 into 6 into 10 to the power 24. My dear student, now all the values are put in the formula and now let's start solving the problem. M2 is equal to 3.5 into 10 to the power 22 into 1.5 into 10 to the power 11 square. So we can write here 1.5 into 1.5 into 10 to the power 11 into 10 to the power 11. And at the denominator, we have to write 67 into 10 to the power 11 into 6 into 10 to the power 24. Now, my dear student, what will we do? We will take 10 to the power notation to the one side and rearrange 3.5 into 1.5 into 1.5 into 10 to the power 22 into 10 to the power 11 into 10 to the power 11 upon 6.7 into 6 into 10 to the power 11 into 10 to the power 24. So my dear student, we have taken 10 to the power at one side in order to make our calculation easy. Now my dear student, here we can write M2 is equal to 3.5 into 1.5 into 1.5 into 10 to the power 22 plus 11 plus 11 upon 6.7 into 6 into 10 to the power minus 11 plus 24. So my dear student, if we add M2 is equal to 3.5 into 1.5 into 1.5 into 10, and if we add 22 plus 11 plus 11, we get 2, 3, 4. 2, 3, 4. we will get 10 to the power 44. Now my dear student, divided by 6.7 into 6 into 10 plus minus sign of a greater number. So 24 minus 11, what will we get? 4 minus 1, 3, 2 minus 1, 1. So greater number is 24, so it will be 10 to the power 13. So my dear student, now M2 is equal to 3.5 into 1.5 into 1.5 into 10 to the power 44 will write, and at the denominator will take 6.7 into 6 and 10 to the power 13 will take at the numerator, so plus will become minus, so 10 to the power 44 minus 13 we can write. So my dear student, 44 minus 13, 4 minus 3 we get 1, 4 minus 1 we get 3. So here we can write M2 is equal to 3.5 into 1.5 into 1.5 into 10 to the power 31, in denominator 6.7 into 6. Now my dear student, this step I will write again one more time. M2 is equal to 3.5 into 1.5 into 1.5 into 10 to the power 31 upon 6.7 into 6. Now my dear student, here we have to shift 1 to 3 digit so that we will get the whole number. So we will do one thing, M2 is equal to 3.5 into 1.5 into 1.5 into 1000, will write into 10 to the power 31 as it is. Here we will write 6.7 into 6 into 1000. My dear student, in order to remove point, we have to remove 3 digits, and therefore we have multiply the numerator and denominator by 1000. Now my dear student, by doing this, 3.5 will become 35, 1.5 will become 15 and 1.5 will become 15 upon 6.7 into 6 into 10 cube we can write, and this 10 to the power 31 will write as it is into 10 to the power 31. Now my dear student, we get M2 is equal to 35 into 15 into 15 and into 10 to the power 31. My dear student, here 10 to the power 3 we can take it up. So when it goes to the numerator, we have to subtract, and therefore 10 to the power 31 minus 3 we will get, and the denominator we will have 6.7 into 6. Now my dear student, M2 is equal to 35 into 15 into 15 into 10, 29, 30, 31. So here we will get 10 to the power 28 upon 6.7 into 6. Then M2 is equal to 35 into 15 into 15 into 10 to the power 28 divided by 6.7 into 6. Now my dear student, here we have to remove one more digit. So what? The point from the denominator. So M2 is equal to 35 into 15 into 15 into 10 to the power 28 upon 6.7 into 10. We have multiplied here with 10. So in the numerator also we have to multiply it by 10 into 6. So my dear student, here M2 is equal to 35 into 15 into 15 into 10 to the power 28. Here 1 will come. So 28 plus 1 upon, this point will be removed, 67 into 6. Now my dear student, here we can do one thing. M2 is equal to 35 into 15 into 15 into 10 to the power 28 plus 1, 29 upon 67 into 6. Here my dear student, now the point is removed and we have also made it very simple. So when you simplify it, my dear student, you will get 35 into 15 into 15 upon 67 into 6. You will get an answer, that is M2 is equal to 19.58. My dear student, I am directly writing the answer because the step is simplified, and now you have to only do the multiplication and division and you will get the answer 19.58, and 10 to the power into 10 to the power 29 as it is. But my dear student, we want answer in 1 point, and therefore we have to shift the point towards the left side, and in order to do this we will shift 1 point towards the left side, and then our answer will be 1.95 into 10 to the power 30, and it is the mass of the sun and the unit will be kg. Therefore, the mass of the sun will be, I'll write here, 1.95 into 10 to the power 30 kg. Let's study the next problem. Welcome back, student. Today we are going to study some numericals of physics. Chapter number 1, Standard 10, Gravitation. Let's study the next problem. Assuming that the earth performs uniform circular motion around the sun, find the centripetal acceleration of the earth. My dear student, here the earth is said to perform uniform circular motion around the sun. We have to find centripetal acceleration of the earth. The speed of the earth is given, and that is 3 into 10 to the power 4 meter per second. Distance between the earth and the sun is given, that is 1.5 into 10 to the power 11 meter. My dear student, we will first write down what is given to us. Speed of the earth is given to us, which is 3 into 10 to the power 4 meter per second. The distance between the earth and the sun is radius, and so r is given, that is 1.5 into 10 to the power 11 meter. Here, my dear student, you have to find centripetal acceleration of earth. My dear student, we know one formula, that is of centripetal force. Centripetal force is equal to mv square upon r. My dear student, we also know one formula of force, that is force is equal to ma. Now, on this understanding, my dear student, we can derive the formula of centripetal acceleration and can easily find the centripetal acceleration of the earth. We can write mv square upon r is equal to ma. Will get cancelled. So here, my dear student, we get a formula A is equal to V square upon R. Now, my dear student, in standard 8, we have studied uniform circular motion. And here, the earth is said to perform uniform circular motion. In uniform circular motion, the object moves in a circular path with constant speed. But my dear student, the direction of the object is changing at each and every point. And we have studied that whenever the speed is constant, but still if the direction of the object is changing, then such type of motion is said to have velocity. And therefore, my dear student, here we have got the formula where A is equal to V square upon R. We have derived. But this is uniform circular motion. The speed is constant, but the object is changing its direction, and as the object is changing its direction, it is said to be having velocity, and therefore we can write this value of speed as the value of acceleration. Now, my dear student, here we can write A is equal to V square upon R is equal to speed. We can put the value as discussed earlier, 3 into 10 to the power 4 meter per second square upon the radius is given to us 1.5 into 10 to the power 11 meter. So my dear student, here we can write A is equal to 3 into 3, that is 3 square, into 10 to the power 4 into 10 to the power 4, because 10 to the power 4 square is there, and here we can write 1.5 into 10 to the power 11. Now my dear student, here we have put the value and removed the bracket. So A is equal to 3 3s are 9 into 10 to the power 4 plus 10 to the power 4, the power we can add. So we can write here 10 to the power 4 plus 4, 8, divided by 1.5 into 10 to the power 11. My dear student, here A is equal to 9 into 10 to the power 8, and 10 to the power 11 we can take in the numerator. So plus 11 will become minus 11, and 1.5 we will write as it is. Now my dear student, A is equal to 9 into 10 to the power 8 minus 11. 8, 9, 10, 11. So minus 3, 8 minus 11 we will get minus 3, because 11 is a greater number and its sign is minus. So we have minus it and given the sign of a greater number. And here we have 1.5. Now my dear student, we have to remove this point, means we have to shift this point one digit ahead. What we will do? We will multiply it by 10 in the denominator, and in the numerator also we will multiply it by 10. So my dear student, here A is equal to 9 into 10 to the power minus 3 and 1.5 into 10. In order to remove the decimal point, we have multiplied by 10 in the denominator, so we have to also multiply it by 10 in the numerator as well. So my dear student, here A is equal to 9 into 10 minus 3 plus 1 upon 1.5 into 10, so point is removed, so it will become 15. So my dear student, here we can write A is equal to 9 into 10 minus 3 plus 1 plus minus 3 minus 1 is 2, greater number is 3, sign is minus, so we will take it as minus 2, and 15 will come as it is. Now my dear student, 3 3s are 9, 3 5s are 15. So here we can write A is equal to 3 into 10 to the power minus 2 upon 5. Now my dear student, will divide it. 5, 3. 5, 0s are 0, minus 3, point will put here, will take 0, 5, 6 are 30, 0, 0. So my dear student, here A is equal to 0.6 into 10 to the power minus 2 we get. Now here my dear student, the value is very less. So we will convert it. We will try to shift the point one digit ahead. So I have told you, if we want to shift the digit one digit ahead, what we do? 0.6 into 10 divided by 10 into 10 to the power minus 2. So my dear student, here 0.6 into 10, when we multiply we get 6, at the denominator we get 10, and here we get 10 minus 2. Now my dear student, this 10 to the power 1 we can take it in the numerator, and then we can write A is equal to 6 into 10 to the power minus 2. This is plus. When it is taken up, it will become minus. So A is equal to 6 into 10 minus minus plus 2 plus 1 3, sign of a greater number minus 3. So my dear student, here we get the answer A is equal to 6 into 10 to the power minus 3. It is acceleration and the unit of acceleration is meter per second square. So this is the answer, my dear student. The problem was very easy. Thank you very much. Next study the next problem. Two spheres of uniform density have masses 10 kg and 40 kg. The distance between the center of the sphere is 200 meter. Find the gravitational force between them. My dear student, this is a very easy problem. Two spheres are given, their masses is given and the distance between them is given. So let the masses of the two sphere be M1 and M2 respectively, and the distance between them be R. Now my dear student, will write what is given to us. M1 is equal to 10 kg. M2 is equal to 40 kg. The distance between them R is given, that is 200 meter. My dear student, here find the gravitational force is asked. F we have to find, but my dear student, here gravitational constant is not given. So capital G, the value you should learn and keep in mind. If it is not given in the question, you should know the value of capital G in order to solve the problem. Capital G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So my dear student, here we have a formula. F is equal to G M1 into M2 upon R square. Let's put the value. F is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square into mass is given 10 kg into M2 is given, that is 40 kg, and it is divided by R square, and the distance between the two masses is 200 meter square. So my dear student, here we have put the values in our formula. Now we will try to solve it. F is equal to 6.67 into 10 to the power 11 into 10 into 40 upon 200 square. F is equal to, my dear student, will write 6.67 as it is into 40 as it is into 10 and into 10 to the power minus 11, and 200 square we can write 2 times 200 into 200. My dear student, we have arranged the values in such a way that we have taken 10 to the power at one side and simplify it. 200 square means 200 into 200, and 10 to the power we have brought one side. Now my dear student, again we can make it very simple. F is equal to 6.67 into 40, we can write 4 into 10 into 10 into 10 to the power minus 11 upon 200, we can write 2 into 100 into 2 into 100. My dear student, this we have done in order to get 10 to the power to simplify the step. So F is equal to 6.67 into 4 into 10. We can add all the powers. So 1 plus 1 minus 11 we can write. Here my dear student, 2 into 100 means 2 into 10 square into 2 into 10 square we can write. F is equal to 6.67 into 4 into 10, 1 plus 1 2 minus 11 upon, here my dear student, we can do one thing, 2 2s are 4 we can write into 10 to the power 2 into 10 to the power 2. F is equal to 6.67 into 4 into 10 to the power 2 minus 11, we will get 9, 10, 11, minus 9 means the greater number is 11, its sign is minus, so we have minus it and given the sign minus 9. Here my dear student, 4 will write as it is, and 10, 2 plus 2 we can add. So F is equal to, my dear student, here we can cut it. 4 get cancelled, 6.67 into 10 to the power minus 9 upon 10 to the power 4. My dear student, F is equal to 6.67 into 10 to the power minus 9, 10 to the power 4 is in denominator, we can take it in numerator, so plus will become minus, so we will write here minus 4. F is equal to 6.67 into 10 to the power minus plus sign minus, 9 plus 4 13, but the sign will be minus, so minus 13. So force is equal to 6.67 into 10 to the power minus 13, and the unit of force is Newton. So this is our answer. Find the gravitational force between them. You can write in the words also. The gravitational force between them is 6.67 into 10 to the power minus 13 Newton. Let's study the next problem.